Hello friends, welcome to Risingpearl.com. We just have started a new series 3 called Trigonometry. Today is webisode number 2, and friends, today's topic is taking a look at right triangles. So what do we mean by taking a look at right triangles? Let's look into it. Now friends, in our webisode 1, or which was the first introductory video on our webisode 3 Trigonometry, we looked at trigonometry. What is trigonometry? Trigonometry is nothing but it is the branch of mathematics that deal with study of relationship between angles and sides in a triangle. That is what is called as trigonometry. So I have drawn a simple triangle here, ABC. So these are the angles, angle A, angle B, and angle C. In the last webisode, we looked at how if we change one angle, it totally changes the whole triangle. That is, it affects other angles and all the three sides. Similarly, if you were to change one of the sides of a triangle, it also impacts the other angles and other sides. Now friends, here one simple observation is, so when we are looking to understand the relationship between angles and sides, so first of all we need to draw some sort of a triangle, right? Now, in how many ways can we draw a triangle or any triangle? So as you can imagine, here friends, just for fun, I have kept the length of the side BC the same, and I have really tried to show you here that all of these dotted lines are just some of the many infinite ways in which one can draw a triangle with the same side BC. Obviously, you can imagine that I could have actually changed the length of the BC as well. I could have made it smaller or larger. So the point we are trying to make, friends, is that there are really infinite ways in which I can draw a triangle. So the question is, where do we begin our study of trigonometry in terms of the angles? So the answer to that question is we are going to start at right triangles. So why right triangles? Why not other kinds of triangles? So why will we start at right triangles? Before I answer that question in just one moment, let us just quickly refresh our memory as to what is a right triangle. So here friends, I have drawn some right triangles for you. Right triangle is nothing but a triangle that has one side 90 degrees. So in this triangle, this angle, one angle is 90 degrees. So here this angle is 90 degrees. Here this angle is 90 degrees. In this particular triangle, this angle is 90 degrees. So as long as I have one angle in my triangle equal to 90 degrees, that is what is called as a right triangle. So let's go back to the original question. Why will we start our study of trigonometry at right triangle, not any other kind of triangle? To answer that question, friends, let's take a look at this scenario. So we are going to observe right angles in nature, and you will be surprised that most of the time when we observe things, we are really talking about right triangles, and I'll show you how. So here imagine, this is a person obviously, as you can imagine here. So pardon my drawing. Let us say this is me, or this is you, or this is one of us, or our friends, or your friends. This is basically a person, right? And this is, I have tried to draw a tower. Well, this is the most beautiful tower in Paris. Let's just say this is an Eiffel Tower for conversation's sake. It doesn't really harm, right? So here, friends, I am standing here on the ground, and I am in front of Eiffel Tower. So now, if you were to imagine that you are looking at the top of the Eiffel Tower, right? So essentially from your eyes, right, you are just tilting your head up and you're looking at the very top of Eiffel Tower. So this imaginary line, this line is called line of sight. This is called line of sight, and this is basically, there is no solid line that really is happening between your eyes and the top of the tower. Essentially, well, we are not really getting into the physics and the lights and the rays. Uh, Essentially, obviously, when the light ray reflects off an object and you see it, that is how you have this line drawn. But from our standpoint, from mathematics standpoint, all I'm doing is I'm looking at the top of the tower and I have drawn this line of sight, which is a straight line that I'm looking at the top of the tower. Now, also at my eye level, if you draw a horizontal line, which is so essentially, this is my ground, right? So this is basically the ground or the ground level or earth, you know. So essentially this is the ground, and here I have drawn a straight line which is parallel to the ground. So it's a horizontal line which is parallel to the ground level. It is at my eye level, right? And then I can imagine that right through the middle of the Eiffel Tower, I can have an imaginary line like this, which can go right through the middle of an Eiffel Tower, right? All the way to the ground. So friends, as you can see, so what happens here is this is a 90 degrees. This angle is 90 degrees. So why? Because the ground level is straight line like this, and Eiffel Tower, or any tower for that matter, is standing straight upright. So the angle between this object and the ground is, that angle is 90 degrees. So friends, now if you were to observe, let's just take a look at it one more time. Now it is not just the tower. Imagine any building, right? It could be any building, it could be any tower, it could be a tree, it could be a mountain, and as a matter of fact, it could be even planets and stars or galaxies. Now, most of these things, when we look at them in relation to where we are located, we look at them straight, and they basically are at 90 degrees, right? Actually, planets would be a little bit more complicated, and you can argue, like you can imagine, instead of this tower, you can think about like a building, maybe a tree, even a mountain. All of this, so just for just for the fun of it, if you would have thought there is a mountain like this, right? Not all mountains, would be obviously in the form of like this, right? But we can imagine right through the middle of whatever the object we are visualizing, we can draw this imaginary line, right, straight down, and imagine that that intersects the ground at a 90-degree angle. So friends, again, just wanted to express the fact that right angles or right triangles, they exist everywhere in nature. So we are going to start the trigonometry, or this understanding of the relationship of angles and sides. We will start that with right triangles. Now, one other quick example would be that, imagine you are standing here and you are looking at a hot air balloon, right? So this would be our line of sight. This is our line of sight. Let's just write it here. Right? And this is the height of the balloon from the ground. And this is the horizontal line at our eye level. This angle is 90 degrees. And here we have a right angle triangle, or right triangle. Similarly, maybe you are looking at another balloon, hot air balloon, a little bit far away. Right? For that balloon, our line of sight is now this one. When we are looking at it this way, this is our line of sight. This is the height of the balloon from the earth, and this angle is 90 degrees. So friends, again, some more examples of how we can imagine right triangles everywhere. And that is why we will start our analysis, understanding of trigonometry at right triangles. So one final thing, friends, is that it is not always that you're looking up, right? Also, now again, this time, as you can imagine here, I have moved myself up here. It's not like I'm hanging in. So just imagine this is some sort of a building. So imagine this is some sort of a building, right, where I'm just running out of space here. So this is some sort of a building and I'm at, let us just say 10th floor or 12th floor. So I just basically have tried to show you that I am not at the ground level. Instead, I am higher above, high up somewhere. And in this case now, this is my same thing. This is my ground level. And my location is that I am not at the ground level, but I am at a higher elevation. And now in this case, instead of looking up, I'm actually looking down. So in this case, I have a plant here and I have a double-decker bus. So if I were to look down at the plant, so again, this would be my line of sight. This would be my line of sight. I'm looking straight down at the plant. I can imagine like a line parallel to the ground level right over here. And also I can imagine the height of the plant is going to go right through the plant, right? So this little line here, this length is actually the height of the plant itself, right? And now this is the angle. Actually, earlier we did not talk about what is that we call that angle. We'll just discuss that in a moment. Whenever you're looking down, right? So in this case, so here essentially just to complete a conversation, this is a 90-degree angle. Similarly, if you were to think about the double-decker bus, in that case, this is your line of sight. This is your line of sight for the double-decker bus, right? And you can imagine a straight line going right through the middle of the double-decker bus. And this length, right? This length actually gives you the height of the double-decker bus. This is the height of the double-decker bus. And then you can draw a straight line parallel to the ground level going into the building. And then this will be your 90 degrees. So friends, whenever we look down, so these angles right here, this angle, or for the double-decker bus, this angle, whenever you're looking down, these angles are called angle of depression. Whenever you're looking down, these angles are called angle of depression. So I should have mentioned this, that what about when you are looking up, right? So let us go back and find out. So whenever you're looking up, so in this case, or like for example we looked at here, right, this angle, whenever you're looking up, so this angle is called angle of elevation. Elevation, you are just looking up, and depression is you are actually looking down. So this particular angle is called angle of elevation and the other one is called angle of depression. So friends, now as you can appreciate, why do we see so many right triangles in nature, right? So some observations, clearly we know there is some sort of a relationship that exists between angles and sides in a triangle. We saw that. We have also realized we can draw any triangle really in infinite number of ways. So when we have to start somewhere, because there are so many right triangles in nature, because every time you look at where your reference point is, you're standing on the ground or the earth, so that is flat, and then whatever the thing that you're looking at is basically standing upright at 90 degree in relation to the earth, that you have right triangle everywhere. So there are so many right triangles that exist in nature, and so we are going to start our study of trigonometry with right triangle.